And mathematics is basically all the formal languages, and constructive mathematics is the subset of mathematics that actually works, that you can implement on computers. I think to exist means to be implemented, and there are parts of mathematics that don't work, and they have in the header file some kind of definition, for instance, that you are in this function is going to has a value with infinitely many digits in it, and after you've read all these digits, the universe can go to the next step, and such a function cannot be implemented, of course. But under the hood, you can do a good approximation, and you just do the first 20 digits, and it's good enough. Or you have some process that gives you more and more digits the longer you compute, but you never get to the last one, and you work in parallel. So in practice, you can work with the header files of classical mathematics as long as you bear in mind that this is not the foundational structure of the universe, because it cannot actually be implemented. And what Gödel has discovered, and others, if you assume that it could be implemented, then your computer will break. So there's basically no computer anywhere in mathematics or in the universe that is able to run this kind of non-constructive mathematics. And if you look at the start of mathematics, we can look at the hypothesis that reality itself is a mathematical object. Then there is the idea that everything that can be known is mathematical because it needs to be represented in some kind of language, and mathematics is the domain of all the languages. And then there is the hypothesis that minds are what does mathematics. So all mental mathematics, or mental activity can be described in mathematical terms. And the classical mathematicians say that there are some mathematical objects that cannot be computed, that cannot be constructed, but they nevertheless exist. And the computationalists say, no, that doesn't make sense. You are hallucinating these objects. You cannot just posit the existence of these objects. And we can show that if you actually do this, at some point you run into contradictions. And instead, what you have to do is you take a simple table of automata, and then you can build everything up from this table of automata. And there are many ways in which you can do that, and they're all equivalent. And that's called the Church-Turing thesis. So it doesn't really matter whether you use Python or assembler or BASIC or the Turing machine or the lambda calculus. They all do the same stuff. They just let you think about this in different ways, but they can all be compiled into each other. And of course, there are some philosophers which don't believe that, which take Gödel to mean this the other way around, which basically say there are some proofs that only humans can make, that computers cannot make. And if this was the case, then I would expect that OpenAI has some people who make sure that certain proofs don't get into the computer because it will blow up the data center. And only people can make those proofs. And surprise, there is no such mathematician working for OpenAI or philosopher. There is no group of people within OpenAI that's actively looking for proofs that cannot be done in the computer, that can only be done by humans. Instead, everybody who works in these companies quite naturally assumes, yeah, okay, there are some things that the computer cannot do at this point, but it's not because it doesn't fit into the computer, but only fits into human brain, but it is because our current training procedures and learning algorithms and ways in which we optimize them and so on are too dumb.